How did you get to building robotics for construction?
For me, it all started from a love of machines. I think machines give people superpowers.
What were the key learnings out of that experience?
The things that always instilled on me is robots in the real world. You can do a lot of things in the lab, but until you actually go out and figure out how they're going to fail, you don't really know what you've got. And so that always stuck with me. That's a big philosophy of ours at Canvas, and was a huge learning there.
What was the spark that led you to start Canvas?
Started realizing that we're in this kind of crisis moment in construction where in the next 10 years, we're going to start seeing our buildings production completely slow down, and we're not going to hit our building needs.
Hey everyone, and welcome to BitBuilders, where we sit down with the greatest minds building and exploring robotics in construction and space. Before we get started though, if you're a startup founder or operator responsible for innovation in your company, or you want a deeper, more insightful look into technology in AEC, you won't want to miss our newsletter. From deep dives into particular technologies such as AI, robotics, design, software, and so on. Hot takes from investors betting big in AEC technology, and advice on building tech companies, including the stories and takeaways of the most successful AEC technology founders. Head over to www.bricks-bytes.com and sign up today to get this exclusive material straight to your inbox. And now for the episode.
Hello, hey Kevin, welcome to BitBuilders.
Hey Gabriel, good to see you. Thanks for having me.
Of course, all my pleasure. Why don't we start with just your introduction, Kevin? You're on BitBuilders podcast. Why do you think of that?
Yeah, absolutely. So Kevin Albert, co-founder and CEO of Canvas. Great to be here. Obviously, we're working hard to revolutionize and move construction industry into the future with new sets of robotic tools. And so excited to talk with the crew here today.
And I love it. It's a modest enough introduction. I think a lot of people equate the construction robotics space with Canvas, or at least put it at the top of their market maps. You've been, one of the businesses out there that has raised the most money to build construction robotics tooling and really revolutionize how trades are operated. We'll get into that really soon. But I always try to run the interview around the interviewee. So I try to just want to ask, hey, how did you get to that? How did you get to building robotics for construction? So, what was your upbringing? What did you study? What was your early career like? I'd love to hear that, kind of nexus story.
Yeah, it's always funny to hear people talk about us as kind of the leaders in the space. And of course, we were one of the first out of the gate and have pioneered a lot of things at Canvas and kind of, set the path for a lot of others. But, when you start doing it, you kind of do it out of the passion for what you want to see in the world. And you do it from, a couple people in a room. So you always kind of feel like that persona. So it's always funny to hear the reflection of the work we've put in over the last, 7 years. But for me, it all started from a love of machines. I think machines give people superpowers. Cars will let us travel distances we never were able to before, and then and planes get us even further distances. Excavators are a great example from construction. So that's always been something that's been a thread for me, is how do we make better machines that allow us to do things we otherwise couldn't. So I was an engineer, and wanted to figure that out. I gravitated towards control systems, which is, okay, how do you make machines do what you want them to? And so that led me to MIT and Boston Dynamics, where I spent a bunch of time working on walking algorithms for robotic dogs. And that was an amazing job. And we spent a lot of time understanding, how do you get machines out into, unstructured environments, places where machines have never really spent time going, at least robotic machines, which gave us the understanding that, hey, we can handle these more dynamic spaces. You're not stuck in a manufacturing facility anymore. Machines like robotics can go out in other places. And so that paired with I worked construction in high school and college. I got to dig holes as a laborer and knock down buildings and do demo, which was great, awesome physical work. But I also woke up every morning with my hands like stuck in the shape of a shovel or a sledgehammer. So as I would like warm them up for work, go hit 32 ounces of Mountain Dew and get back out on the site, it kind of stuck with me as I was working on these robotic systems on like, hey, we have great machinery in construction that give us massive capabilities. The example we like to say is you used to dig holes with a shovel. Someone invented the excavator, and now those workers are driving this machine. They have massively more leverage, and their careers have become safer, more lucrative, et cetera, et cetera. And it's like, why aren't we doing that more across construction? And so that was really the spark that got us going on this on Canvas.
Yeah, I mean, I think what you just said is the guiding principle of robotics technology is having leverage, right? And
yeah,
I mean it in a physical sense. Leverage as in literally just the product of the force and the distance from the what's it called in English? Like the center of motion.
Yeah, exactly.
And I love that because it's a concept that we try to instill a lot in the industry when we speak with, general contractors and trade contractors, and also even just heavy equipment manufacturers that are looking at their new lines. I think that's something that they're looking for, increasing leverage for their own operators. And I'd love to understand, in your time at Boston Dynamics, many recognize in the industry as one of the places where you can learn the most ambitious, certainly the ones that have pioneered a lot of the, kind of like novel way and design philosophy around making robots. What were the key learnings out of that experience? And also, how was Boston Dynamics as a working?
I mean, first, I just want to call out what a great place Boston Dynamics was. I had an amazing time there. It's a fantastic place to work. The people are all phenomenal. Just intensely curious about the world, but also really smart people and really, really good people as well. So loved working there. It was a really good environment. I learned a ton from everybody around me, and just also the kind of nature of experimentation. That was a lot of what it was, is like, go put things in positions that they haven't succeeded before and figure out how to make it, you can go fail a bunch and figure out how to make it succeed. And so, that's what the philosophy was. Like, there was a park next to the office, which was, just had all this rough terrain and stuff. And it was like, you just went and took the robots out there, and you kicked the robots just to see how they would fail, so you could find out, all the different ways that it wasn't going right. So that was one of the things that like always instilled on me, is like, robots in the real world, you can do a lot of things in the lab, but until you actually go out and figure out how they're going to fail, you don't really know what you've got. And so that always stuck with me. That's a big philosophy of ours at Canvas, and was a huge learning there.
No, I love that philosophy of causing failure. Try to, it's the troubleshooting that you can do with code. Yeah. With code, it's easier because in the terminal, it just doesn't run. And it's a bit easier because you can actually go in the code and troubleshoot. But then when every single time you have to upload that code onto a robot and see, okay, let's see how it fails. And let's see if I can really trace it back to what failed. Yeah. Why did the robot, roll on the right place and redeploy the leg. It's super interesting. And actually, I worked in a biorobotics lab for one of my high school internships. It was funny because like this high school kid like paired with the PhD in biorobotics, I couldn't help much, but I did really just learn. And there was this underwater terrain walker that you can just the model of a leg that's bouncing in the bottom of the ocean, so you can explore shipwrecks.
Oh, cool.
And it's always super cool, right? And I remember that was an easy one because actually Archimedes was helping you because you have buoyancy of the robot, and it's actually easier to jump in water and control the descent. And so even that was already an extremely difficult problem. And when I look at Spot today, Boston Dynamics, it's like, how do we get so seamless in movement and control? And I love it. So it's super cool to talk to someone that has contributed.
Thanks.
What's your what was the spark that led you to start Canvas? What was the thesis around, the initial days of the company? Yeah, how do you describe the Nexus story?
Yeah, we actually kind of have an interesting founding story. So after Boston Dynamics, I joined up with Other Lab out here in San Francisco. And Other Lab is kind of it's a research lab in ways that we do a lot of government contracting. But the goal for all of that research is always to commercialize. And so we were working a lot on projects with the government, with DARPA, NASA, ONR, folks like that, who are great backers, and exploring a bunch of different things around the thesis of like, hey, we know how to get robots out into the world now, outside the factory. We can handle unstructured environments or more dynamic areas. Okay, so like, what is the right form to do that in? Where are the needs? And we even experimented with some really crazy stuff like inflatable robots. So if you've ever seen the movie Big Hero 6, which maybe if you're kids you have, that was actually inspired by some of the robots that we pioneered at Other Lab. And the idea was like soft, fluffy robots are great in the real world. Unfortunately, what we realized in doing that is that if you put anything dangerous in the hands of a soft, fluffy robot, it's still a dangerous robot. So it's not actually the softness and the fluffiness that makes it really good in the world. And so, more fundamental learnings. But in that work, we started really working on aircraft finishing as one of the kind of projects. And we were doing some work with Toyota at the same time and doing some automotive finishing. And automotive finishing is like you bolt the robots to the ground. You have 8 robots and the car moves in, it gets painted, and the car moves out. And the robots always know about where the car is going to be and never have to move. And then when we were working on the aircraft, you couldn't do that. It was too big. And so the only way to do it would be to move the base of the robot. And it was clear that was actually a barrier, because all of that calibration and tolerancing that you'd get in automotive just wouldn't be there. And so, doing aircraft finishing at places like Airbus or with the U.S. military was all manual. It was all on scaffolding, people in bunny suits, sanding entire fuselages, right? Like multiple times to coat them. And we kind of took a step back, and as we started pulling on that thread, we saw that like that existed in bridge refinishing, in tanks outside, in buildings. And then we took it a step farther back, and we saw that in all these larger spaces where you really needed to move around but still be precise, the ability to calibrate to that space and the ability to actually like do good continuous work with robotics, it just wasn't there yet. And so we realized there was a fundamental thread that we knew how to solve, that existed throughout the world. And so what really got us going, I mentioned my history in construction, is we started looking into the numbers. And I think we've all seen like the McKinsey report on construction dropping productivity. We've all seen the numbers of demographics shifting, right? Like we're retiring 2 people for every 1 that enters the industry. And we started realizing that we're in this kind of crisis moment in construction where in the next 10 years, we're going to start seeing our buildings production completely slow down, and we're not going to hit our building needs. And so we got really focused on, we've got a problem here that robotics is ideal for, but we don't have a core technology yet to handle these kind of large spaces. And we have a massive problem in the world that really needs to be solved because it's fundamental to everything we do. So that's when we really turned towards it. And it wasn't until we met a bunch of hotel owners, and did a bunch of tours with them, and they were just like, our biggest pain is we have to flip our walls every 5 years because of the wear and tear. It's high use, high traffic area. And man, the drywall finishing is just killing us. It's super labor intensive. It's dirty. It's slow. And, it's hard. We're having harder and harder time finding the skilled labor we need for it. And they were like, could you do this? And we were like, yeah, we know how to do that. And we for like 3 months before we committed actually to doing it, we actually ran a competition inside the company to see, and we split into 3 teams to see which team could figure out how to do drywall finishing with robots. And so we named them Team Box, Team Hot Mud, and Team Spray and Pray. And ultimately Team Spray and Pray won. which was a surprise to everyone, but it actually set us on this path of this kind of like new reinvented process to do drywall. So that's how we kind of got there. It was this larger kind of search.
It's super interesting that did not know at all that this came from painting fuselage of planes.
Yeah.
As the initial use case. Like fuselage of planes of what? 500 square meters surface area is very large.
Yeah. No, huge surface area on planes. And and you have to do it multiple times. It's still a huge need. Honestly, there's a good opportunity for it out there.
You can maybe go back to the initial idea. They're expanding business lines.
Right.
No, but I love that crossing. So you had the ingredients where the fundamental technology was there, or at least the control system was already thought to work in that way. You had the data, but then you needed that customer. And then at the intersection of these three, that's where you found just the inspiration to build this. How did you assemble the first team? How did that first team come along?
Well, that was a little bit different, I think, than most startups, because we had been doing government grants for a little while. So the team at that time, we already had 10 people on board and had a good cohesion and kind of like a full engineering team. So that was a little bit of an advantage that we had at that time. Originally, it was, the team was slowly built up through the government grants. Right as we got going on the government work in 2014 was when I met my co-founder. Well, that's not when I met her, but she had moved out to the Bay Area, Maria Telleria, who's our CTO at Canvas. I worked with her at Boston Dynamics when she was at MIT. And we worked on all kinds of like interesting robots, together, collaborating. And so when she moved out, we've always kind of like shared this vision. And so, we slowly built up that kind of research lab together. And then when we were in 2017, when we kind of said like, no, we're going to kind of put that all aside and we're going to be a drywall company to start. She actually went and got her contractor's license. So she holds a contractor's license for drywall finishing. And we started subcontracting work.
I love it. It's something that I think most people at MIT did not get into that's not what they thought they would be doing. Most MIT graduates want to work on, aerospace and stuff that's really difficult and just a phantom and in construction. From the outset, it seems like an obvious thing that you take for granted. But in the end, if you see how much technology you need to truly revolutionize it, it's actually even harder because you have to introduce it in a place that has had a lot of friction for innovation.
Oh, yeah. I mean, it's funny your comment about aerospace. I was like, we are working on it. We're working on the new frontier, because honestly, I think this is harder. And not to take anything away from people who make rockets. That stuff is cool and hard. I worked at a thruster for making thrusters for satellites way back in my career. But people talk about construction being like slow to adopt. I don't think. I think there's plenty of conversations about labor and all those types of things, but I don't think the industry is actually slow to, like, the people are not slow to adopt. They actually want new, better tools. But I think the nature of the industry is so dynamic and complex, that it is kind of like more difficult and more, and that's why we haven't seen this type of technology in it. I mean, the big example, right, like, is any place you're building something, whether it's aerospace, automotive manufacturing, you're in a fixed environment where your manufacturing floor is at least the same manufacturing floor every time. If you think about construction as a form of manufacturing, because it really is just building, literally every single manufacturing floor is different. And you don't know what it's going to look like until you set foot on it, like the day of. And that's a really hard problem, which is really exciting. So, you mentioned, MIT people probably think about themselves working on the hard problems. I think that's where we should all end up, is like, where are the hardest problems that are going to move people forward?
Hey listeners, I want to take a quick break to remind you about the Bricks and Bytes newsletter. If you're interested in learning about the technology shaping the future of construction, you won't want to miss the valuable insights we share each week. To get this exclusive content delivered straight to your inbox, head over to www.bricks-bytes.com and sign up today. Link is in the show notes. back to the show.
And I think there's a huge reflection to do that this has not really been understood by my generation. And I think now coming into our mind that, these are fundamentally, they're just fundamental industries that need to be innovated and need to be replenished with talent and technology. I think just now we're seeing this evolution. And I think the entire project of the podcast is to kind of like group people that are working on this at the forefront together to show to the external world that, hey, there's actually a workforce of extremely brilliant people that are just there trying to solve that problem. And I think that's going to be inspiring for the next generations coming in. If I look at my engineering degree, I vividly remember the application number for like aerospace engineering being much higher than the civil engineering. And because I think my parents, or in general, the generation that's coming before us, didn't really instill us this idea of that working in construction is fun or in any possible way, right?
Right.
So that's probably where the fallacy comes. But I think that's getting fixed. It's getting fixed by the market because there's a clear tool. And I want to double click on this one because I think you are one of the best placed people to really talk about this. Let's kind of like extract ourselves from like the general narrative. Yes, there's a labor shortage in the US and also in Europe. There's some trades that are seeing net new labor being negative, like net labor every year being negative, meaning people are just leaving faster than new ones can join.
That's right.
Let's kind of double click on that. What are the insights that you see every day? Maybe geographical, maybe demographic. Like, how do you unpack in a more detailed way that labor shortage that we're living?
Yeah, I mean, I've spent a ton of time thinking about this. And there's kind of the obvious structural ones, right? That you just like can look at the straight data, right? Like if you look at US Census data, demographics are shifting, and we all knew the baby boomer shift was going, but we're also seeing kind of a general steady trend over time towards less kids than we've had in the past, right? And that's not just in the US. And so we have a demographic shift just happening. So like the core statistics are like, of people working age in the US, 80% today are still in jobs and 20% are retired. So that means like 80% are between like 20 years old and 65 years old, and 20% are above 65 years old. By 2030, that's going to be 70-30, right? And so like, just from the demographics to start, you're going to have less people in each of the jobs that are out there, because it's not like jobs are reducing at all. And so we need to deal with that. On top of that, you talked about the big one, which is that social aspect, right? There very much is like a more difficult to recruit younger generations right now, because it's just not like the social narrative of like the career path you want, and for obvious reasons, right? Like the tools of the trade and drywall finishing are trowels and boxes and bazookas, and those, don't line up with anything we see kind of like at all in media and in kind of our aspirations stuff. Like even our cell phones seem massively more advanced than the tools that we use in construction. And so like, it's not surprising that there's that narrative. But the third piece of it is really interesting because I look at like, what's the educational path and career growth path a lot. And this is actually one of the places I think construction has a big advantage, right? Unions and apprenticeship programs are really strong ways to get paid while getting educated on a career. And that's something that, this narrative of go to college to get a good career isn't necessarily the best narrative across the board. I think we see different things in Europe. And I think Europe's a bit ahead of the US right now in that respect. But I think what we see is like really big opportunities for people to join unions, get trained on robots, get vocational skills as well that are like, the skills for the next century type of thing. And so I think there's a really exciting piece of this that is, how do we think about training and education in the future? And then a little bit of a plug for what we do. We use the data from the machine and stream that to our tech support team. And a lot of times when we get calls from customers, we're actually, it's not necessarily always debugging our robots, which, let's just be honest, it is sometimes. But a lot of times it is, continued training, right? So imagine you have a situation where the union or educators can constantly be with their people, helping them get fully educated in continuous fashion, get good feedback on what some of their pains are and things like that. I just think it's a cool model for, the future of education. I think that's a way we can attract a lot more people into these trades. And then the last piece of it is, of course, the pain of the work, right? The other thing driving people away is that, one of every 4 workers in finishing today and their career with some sort of musculoskeletal disorder, like a rotator cuff injury or something like that. So if we can make these jobs safer, they become a whole bunch more attractive.
Yeah. No, that's fully clear. Safety, education, demographics, and social stigma.
Yeah.
That's like the way you're modeling it. I think on the education part, I think construction and agriculture will see an incredible reversal because we need government policies, and these government policies are going to be unilateral. It's just gonna have to happen because these are the 2 sectors that are seeing a very sharp drop in interest, and I think the governments will have to pay workers to kind of get into those trades. And in Italy, there's this big government intervention that's going on to get people back in the field to become farmers again. And
interesting,
incredible amount of arable land. We have our exports are through the roof, but you can't sustain that if you don't have enough workers. And I don't think, and I feel like Italy is one of those countries that is less inclined to adopt automation at scale. It also doesn't have that culture of investment. It's more of a culture of saving. So it's easier to get that, to give that nudge to the people.
Yes.
It's short term, easier for a country that's not in its best financial condition. But yeah, I see the parallel with the United States and construction, and just with the wider sector in Europe. What do you, so really cool window on the labor situation in the US. I kind of want to close that, trying to understand what it took for you guys to attract talent. My question is leading somewhere, so don't worry. Like, what did it take for you guys to attract the right talent at the beginning? So you have this team of 10 people that was already doing government grants, and as you scaled to a little bit more, what's your team size at the moment?
So we're 26.
Okay.
Yeah.
How did you get that to 26? Meaning, what were you looking for in the new joiners? How do you attract talent for such a niche product in a very complicated industry like robotics?
Yeah. I mean, I think it's an interesting question. You do a lot of searching, you do a lot of interviews. We've certainly used recruiters. We've used a lot of network, and then we've actually had really good success with people actually just coming and applying to the company. And I think it's 2 parts. So it's like, how do you find the people that will be interested? And then also, like, what do you look for in those people? Like, how to find the people that are interested is, it's all about the mission. While this is a super niche application, like what we're doing and this mission is something that a lot of people can get behind. And you just have to recognize that, like, it isn't some people's cup of tea too, right? That's part of the process of the interview. Like, you're going to find someone who's much more inspired by autonomous vehicles. And we've had this situation where this great candidate, and we're trying to, like, we love them, every aspect of them. We think they're a good fit for this. And at some point you just realize that they're going to, like, their mission in life is going to be autonomous vehicles, where we see people at our company that are just like, no, this is the thing in the world we need to solve. And so at first you need to start looking for that. And also that's part of why you need to get the word out about what you're doing and get that mission out. On the flip side, what we really look for, is curiosity, above all else. Like, who are the people who are going to ask the question why and dig deeper? And you have to do that, right? Because, like, in every aspect of this, you can come to an assumption of this is why this is happening. And if you don't ask them multiple times, well, is that really true? So there's something at Canvas we like to say is, like, trust but verify. And that can come into all kinds of different ways. Like, let's say, an engineer comes to you and says like, hey, this thing's calibrated, it's working now, go ahead and ship it. And it's like, well, did we verify that? And then sure enough, you might find out that like, hey, in this case, it actually wasn't quite working yet. And that would be a bad thing to ship out to a customer. And another example is like in a customer situation, right? Like we've had situations where we've applied material and then the end result didn't come out right. And the customer's like, the robot didn't do it right. Or they were like, it's the wrong material. But then when we dug in and really done those experiments to find out what the true root cause was, it was something else completely. And so really kind of going back to that curiosity, that really kind of rigor to go and figure out the root causes and why is something we look really closely for.
So you look for a curious talent. And my question comes because of it's just a deep interest on how do you scale a robotics team to a commercial kind of like degree. So you had this nucleus that I imagine was almost completely technical, where you were working on government grants and maybe I don't know if you had someone in business development for that, but how do you think of scaling those functions in the team so that you are running an R&D process, you are at the same time serving customers and at the same time looking for business? So how was that as a CEO, right? How did you wrestle with that?
Yeah, I mean, the thing that we've tried to do most as we've done that transition is really like look at what we need to measure. And so, as much as we can, the goals can kind of drive the process and we can see, where we are meeting the goals and where we aren't. And so as your goals start coming to things like, hey, we need to get 96% uptime for our customers. And then you say, okay, like, what do we need to be working on to do that? It starts transitioning like, hey, at first, maybe the coolest problem is what you think about. Now it's really like the coolest problem is the thing that makes the customer work. And so starting to do things like that. And then one thing we've been really focused on actually over the last 2 years is that customer feedback loop. So, customer success, product engineering, and having that loop very tightly knit. And so really starting to have kind of like dedicated weekly meetings just focused entirely on that loop to make sure that that's kind of like the thing that's always top of mind is like, what's the problem for our customers and what are we doing to solve it?
What do customers care about in this industry?
They care about, actually, it's an interesting question. They care about ease of use and reliability first and foremost. The thing that they're using has to just kind of work, right? The trowel is never going to have a bug, right? So that's their that's their level, and they can handle a little bit of downtime. We've seen them be pretty cognizant of our process and what it takes to get something new in the field, especially for the forward thinkers in the industry. But really, fundamentally, it comes down to something that works reliably. The second piece is quality. Quality is table stakes. What you're delivering in the building has to match or exceed what workers can deliver in the building. And usually it's the look is you just want it to match, right? There's very, very high skilled workers that do beautiful work, and you don't really need to exceed that because it's the work they do is beautiful. Now there's a lower scale. There's newer workers that are still working to that point, and you'll exceed that. And then really once you get kind of like those are table stakes. It's a production business. Construction is a production business, and whether you're enabling workers to produce more, whether you're enabling them to do it faster, or whether you're enabling a reduction in schedule, in one way or another, that's what really matters in my mind, and certainly in the business that we're in. It's like they have hundreds of thousands of square feet to finish, and at the end of the day, if that's slowing down, there's not that many benefits you're going to give that are going to overcome a slower work environment.
And delivering the right features to create the right impact on the customer is certainly the key thing around shipping a product. And one thing that's around shipping, around making it work on your own P&L, it's I think the conversation revolves more around, what the business model choice becomes, right? And so I really want to try to spar this with you. I've sparred this with all of the construction roboticists that I've interviewed here, plus those that I've interviewed outside. Opinions differ. There's, the people that they think a RaaS that, for the benefit of the audience, like robotics as a service, you can just simply lease your robot. You're a sub, you're leasing a robot. It's one way of doing it. There's just kind of like outcome as a service type of thing, the way that one of our partners at Fundamental likes to describe it, which is basically, I'll just do your wall and you'll pay me for the wall. So you become the sub yourself. And there's all other kind of like ways in between to mix and match these two business models, depending on the workflow and what you're selling. So what's been the idea maze on your business model during this 7-year journey?
Yeah. So honestly, we're a little bit of a case study in all of the above. Not quite all of the above, but because we started as a subcontractor. And so we did the work ourselves. And like you said, we said like, hey, we'll do 10,000 square feet and we'll charge what everybody else is charging and we'll just go do it. And the goal would be to have your technology give you higher margins than others being able to do it. So technology enabled. Right now we lease robots and annual leases to customers. We've done project leases in the past. We don't do that anymore. And so that's more of your kind of, that's RaaS in a way. It's not the usage based RaaS, but it's like basically we're charging a monthly fee for every machine. It's closer to a subscription that you would see in SaaS. And that's how we run right now. That has a lot of advantages to it. And that was the big transition between those two, is running the systems yourself versus having someone else run them. And that's a big jump to make. Because when you're running yourself, your team is incentivized to do it. Whereas someone else is running it, then you're really making a product that's reliable that someone else can use. So the reason we went from the services to the RaaS is what we actually realized is, where we particularly were operating wasn't well set up for a services model. I don't think it's a bad model for companies, especially in construction. I'd actually recommend it. But for us, we were doing just finishing. That's where we have technology leverage today. But subcontractors do hanging, framing, and finishing. So we were a part of a scope that was bought out by a GC. And so that creates a lot of friction if you're saying, hey, such and such general contractor, just split up your scope, take work away from someone else is how the subcontractor will see it, and give it to us. And then they'll do the other part. And that's just a lot of friction across the board. And so, and it also puts you back in a place where you're doing transactional sales. Like no one's buying like 3 years worth of subcontracting services. They're buying, one project at a time type of thing. So there's a lot of reasons that it wasn't a great model. Now, if you had a trade where it was like, you're only doing that one thing and your technology gives you broad leverage across that, and that's the way they already buy it out, I would actually say it's a much better model in that particular situation. So all of this is to say that it really does depend a bunch on your particular market and trade. An interesting thing that I'm seeing, and maybe this is for the founders out there that are curious about the market trends, is as I talk to a lot of investors these days, there seems to be a waning on RaaS that's happening right now in the market. And what people are starting to realize is that RaaS is not SaaS. These two things are not equal. They sound great because they both have recurring revenue and subscription type of things, but what you end up with in RaaS is you have to pay for the robots ahead of time. And so, especially in a world where interest rates have gone up, people are starting to scrutinize that capital efficiency and ask at early stages of companies, can you take that off of your books somehow? And so are there kind of hybrid models where you can bring in cash up front, and not need to use as many instruments to pay for the robots while still getting some recurring. So there's an interesting trend shifting in the market right now that has been, probably new in the last year to two.
And that's interesting because it brought me exactly what I wanted to go about the capital efficiency piece of how do you make this business transition from a lower margin I would say lower margin, lower friction, but in your case, it wasn't, as you said. Because it's usually lower friction in construction to propose to the GC to be the trade sub, right? So you know what they're buying. It's always the same thing. You have liability for that finished product. In your case, it's not, right? But usually it's kind of difficult to transition from this lower margin, higher, smoothness of the sales to higher margin, but this is not exactly what subs are used to. So you need to like step a little bit on their toes. Although I think what the counter argument could be is these are tools and you want them to stay tools.
Yeah, I would say that that's probably a misconception in a lot of ways. Is we have found subcontractors to be great buyers, and we found GCs actually to be slow and laden with lots of red tape and legal and things like that. Whereas subcontractors generally move quickly, make decisions, have centralized decision making, have pretty forward thinking VPs that are looking to the future. And so they're very good buyers, but what makes the transition very hard is the other thing that I said, which is having someone else operate your equipment. That adoption part is the real challenge.
Yeah.
And of course, it's the real testament on how good a product you truly have. Because if you think about scaling a services model, at some point, your workers are going to be so far removed from the mothership that it's going to feel the same way. It just takes longer to get there. But that's the real hard part, right? Like, and if someone's not incentivized to use their machine, like for whatever reason, they can find a way to not do it right. Not out of malice, but just out of like maybe they're just not as incentivized to learn the finer details of how they should set it up, and therefore they'll run it a little off, and what that ends up looking bad for you, right? Is if they run their machine and it doesn't go right, that's your fault. That's not their fault. So that's the hard part in that transition. But that's really also kind of like fundamental to making a good product, is that the user likes it and wants to use it.
And I think what the biggest challenge is technically here is developing a user interface that people can easily operate plus developing that robustness. I'm talking almost physically, like both, right?
Yeah.
You have user interface can be robust. I should be clicking 1,000 buttons at the same time and nothing should break. And I see you smiling. I know it's one of the problems.
It's true. We've been through that. Yeah.
At the same time, you have to make it robust physically. So you don't want it, if it drops, you don't want someone to need an engineering, the masters at MIT to just go down and just put some screws in again. So you want it to be easy. How did you transition to that state of, actually, let me rephrase it. What were the key ingredients to make you transition to that state of the product where you can ship it to a customer, you can sleep at night?
I don't know. Honestly, it's a focus on it. Like I said earlier, I think is knowing that is one of your core focuses and making that a priority. And so, as much as you can measure it, that becomes really important. Because I can put it as a key goal for folks. It takes time. You have to test it and you have to iterate on it. As much as we want people to be like great designers, it's just like it's going to happen that there's going to be things the world teaches us that we don't expect, and it's going to change. Like you're going to do it in the lab, you're going to test it in your lab, and it's going to be working perfectly, and you're sending a customer and they're going to find something that does wrong. Yeah. And so that's going to be part of the process. And so something I've been thinking a lot about is that I do feel like a lot of times, in these startups, a lot of the push is for you get past pilots, get to revenue, get to commercialization. And, we've gone through that and we're fully leasing to customers now and have gone through that phase. But I feel like there's a good way to work with customers early that brings them into being a partner with you. And it doesn't sound like trying to get them to sign up for commercial contracts when you're still going through that early phase. It sounds like actually reading them into like, hey, this is our phase. Help us get to this commercial contract, but we need to test on site to do so. And I think that's a way to go much, much faster to full reliability, than kind of going out there and trying to say your product is there and having them find out it's not. And so that's something I would probably advocate to folks that are starting up now is really get champions at your customers, read them into what the process is to get to reliability, and find ways for them to help you by maybe it's a quarterly 1 week trial, like every quarter or every 6 months. And you have your champions do that so that you're continually getting on-site testing and feedback in a way that is inspiring the customer into the contract at the end of it, as opposed to setting bad expectations early on.
That's a really good point. The champions within your design partners, we were talking, I was, recording another episode yesterday and today I spoke with another company, not for an episode, and same point, right? Having the champion design partner is what brings you far.
Yeah.
And those people that are truly there for you, they know there's something obviously for them. They probably do it for, just because innovation at school. But at the same time, they know this is going to improve their business massively if it goes through and if you're successful. What did it take for you to find that design partner? How was that? Was it very organic, or was it, like a trial and error, or, hey, this guy is probably not the best?
For us, it was definitely trial and error. And I think, insights often come out of, doing things that weren't quite the right way to do them. And so, we specifically went out, focused on commercialization probably too early. And so we found them through trial and error, but we found them also on like who could stomach that, right? Who was willing to stay with you when it didn't work quite right. So I would say there's probably a better way to do that is you'll find very quickly, like, if someone is willing to run a trial with you and then continue, and then 3 months later wants to run another one and is consistent on this cadence and is putting the work in to give you the feedback, is figuring out what their success criteria is. Those are the things that will become, those are your signals, right? Those are your qualifiers. I think, I've talked to sales leaders in the past, and one of the things that always stuck with me is if your prospect's not doing work for you, then you're not actually making progress.
Yeah.
And I think that's true from a champion and early lead, as well, right? They're going to need to be participating, giving you feedback, as a key part of the process.
And why do you say you went to market, or like, do you focus on commercialization too early? The product wasn't ready?
Yeah. I think I would have, I think if I'd go back to do it again, I would have done a mode that stayed a little bit longer in, further testing with customers and reading them into that's what this was, than trying to, transition to kind of like continuous revenue streams too early.
Yeah, no, that's fully clear. What's another mistake that you think along the journey slowed you down a bit and also made you learn, making sure that these two things coincide?
I know. I mean, I think that's what these podcasts are about. Like if we don't share that stuff, like, technology is going to move slower. So, the two big ones that I point back at, and this is really hardware centric in a lot of ways. The first one is, and this isn't going to sound like amazing or anything, but just really over-index on the most painful thing for your customer and figure out what that is and spec to that. And because, like, if you imagine, hardware is going to take a while to get into the field. Maybe any product will take some time to get in the field and get right. If you can do something that's so painful for them that the crappiest thing in the world that you put out there still makes them happy, like you get these amazing champions early. You get a great product feedback loop going early. It leads to some early revenue too. And customer references are super strong. And even if it's just a small niche part of the market, as long as it extends, like it could be 5 or 10% of the market, but as long as it extends to the overall market, with very obvious, advancements, that is huge, because it leads you to building the right thing, and it leads you to really strong early champions, which there's nothing more powerful for your company. And your thing's going to suck. That's the thing. It's your thing. Whatever you're making is going to suck early on. And so just, know that's true. And that's why finding such a high pain point is really important. The second big lesson was any hardware rev has kind of like a hotel load. So one thing that was a little bit of a misconception early on was, hey, if we don't change much about our last generation of the robot, we'll get the next generation out faster. And it turns out that's not actually true. There's some truth to it, of course, right? There's some logic behind that. But anytime you're going to rev hardware into a second platform, there's going to just be this upfront cost, and it's going to be at least 12 months. And if your team doesn't have the institutional knowledge yet, it could be up to 24 months that the hardware rev is going to take. And so just know that. And again, it goes back to it's a little bit different than software where you can just put things out quickly and fix them along the way. And a hardware rev takes the time, which means you have to take a little bit of the upfront time to know your spec much better before you do that rev, and don't fall into the trap of we'll just rev quickly and only change a few things. So those would be two key ones that I would that I like to give advice to kind of founders, and it's advice I would follow in future endeavors.
No, I love it. I think it makes a lot of sense. Yeah, the lack of the lower speed of iteration is obviously one of the biggest tracks, right? That's quite obvious, and it's but it's interesting that you have to nail the product before it goes out, and that's the hardest part. You have to nail the product before it goes out. So you want the people that are working with you, that are willing to take your, absolutely spotty, drywall finish, and just not very good one, or get sprayed backwards towards the operator because the robot is failing. You want them to be the best.
And just to be crystal clear for everyone who's listening out there, 100% believe the startup mantra that you should be embarrassed of the first thing you put in the field. And if you're not, you took too long. But how you put it in the field is really, really important. And expectations you set around that are really, really important.
And I think I want to bring this back to the capital efficiency piece, especially on one little caveat, which is that of equipment financing, and try to find alternative ways to pay for your CapEx, whatever that's going to look like, right? So at the beginning, you're highly likely not going to lease out the model, not lease out the robot. So that's kind of like the easier way from an operational perspective, because you get an order, you can actually, get one out of your inventory, or even have it built. If your build times, lead times are not too long, and ship it, and you have, zero inventory costs. You're not sitting on CapEx. It's not being utilized. Sometimes, right? Sometimes it's possible, sometimes it's not. But when it's definitely not possible, it's when you basically have a lot of demand, but you're not sure 100% yet that you can serve it all. So it's little bit of that limbo where, hey, should I build more robots, or should I wait for the next generation of design to come in? So how do equipment financing and manufacturing choices interlock in the world of construction robotics?
Yeah, I mean, oh wow, that's a deep topic, and also has massive variation, I think, depending on technology and supply chain and things like that.
I threw you one out there. You should unpack it.
Yeah, exactly. I wish I had here's the silver bullet, do this type of thing. What our experience was, is that lead times and supply chain really, really matter with regards to the dynamics of that question. And so if you have a 9-month lead time, you're taking a lot of capital on really early, and you have to kind of almost just predict where you're going to be no matter what. If you have a 3-month lead time, you can be much more agile to you can start building 4 months ahead on projections that are much, much stronger for that. And if you have a customer base that's willing to pay up front, and then wait for production to come in, which is in some industries, you'll do things like that. You get a huge amount of flexibility from that. But there's some risk that you're going to go a little bit slower because you're not anticipating your demand. And so for me, I think there's kind of like a happy medium. I think equipment financing is really, really good for when you have pretty reliable projections, but you can maximize your speed by building a little bit early. But what we've focused on a lot at Canvas is getting those lead times way down. So things that we do is we have about 20%, 10 to 20% of our BOM that are long lead items and pre-stock those things. And then that gets the rest of it down to a really short lead that you can be really agile. So most of the capital usage is done, not too far before you actually have to field the machine.
So,
And so things like that. So that, and people are, your payback period matters a lot, obviously, as well. And that'll be a huge investor, metric that's going to matter a ton. So pay attention to that. But I would say don't underestimate lead time. That one matters a lot too.
because in the moment that things go well, you need to be able to capitalize on that going well things. You need to be able to deploy if you have a lot of customers, if the product is actually going great. There's a really difficult balance to strike there. I understand that. I threw you a curveball, but I think it makes a lot of sense to focus on lead times. Get your robot to, be able to be built in a few months, and that's it. That's the way you can actually get around most of these issues.
Yeah. I'm sure anyone who has like a 9-month lead time component that's actually pretty expensive to make their technology work is like, well, screw you. Thanks for the advice. That's not useful at all.
Exactly. Or maybe, there's everything is long lead. How did you do that? So how much of that design and those design choices were led by the lead times of your components? I mean, I understand some of the components of your solution are quite commoditized and some others might be more specialized and they might take more time. What was your lead time at the beginning and, in the first version that you shipped, and what is it now? Just to kind of like get a sense.
Yeah. At one couple of years ago, we were looking at like a 9-month plus lead time. And as you started kind of like modeling that out and it just became this, you just, especially with it, you really have 18 months in a funding round to figure out kind of the next proof point. And so you just became very slow and not agile with something like that. And so, the team really focused at it. We just like shared why this is hard and why it's so bad. And again, it goes back to that kind of like emphasis of like a core metric. Like the team looked at it and said like 3 months, lead time's got to be less than 3 months. And so that people rallied around this particular, this focus, and, it leads to the right conversations, and you probably can't always guarantee that you can get under that bar. But people were talking about it, and when they were looking at components, they were looking at it. And so instead of saying, hey, I'm just going to use this component, because it's part of every conversation, you're going to look at 4 more components and see if you have optionality or not. Whereas I think if you're not having that conversation, if you don't have a clear like goal that you want to hit like that turns into like, hey, I found the right component that meets the goals we're actually talking about. Job done. Here we go. Right. So it comes down to that. It's really a lot about driving awareness. And I just, honestly, I'm talking about it as if I did this, my CTO and VP of engineering, like were the huge champions here, and they drove that culture and made that happen. So I get to talk about other people's, great accomplishments,
Wait, this is the perks of the job.
Right. It's all I do, right?
Yeah, exactly. And I mean, it's a form of effective management. Let's call it. But, I love that. Okay. So you really click a lot of times on that concept of driving awareness within your team and be like, hey, this is our goal now. And that's what we have to focus on. Do you see a lot of, why do you think development teams fail? Is it a lot because of defocusing? Do you think a lot of this, I mean, let's 1 second normalize how the market is good to you, right? Let's assume for a second, for a thought experiment, that the market is good to all development teams. Why do you think what are the biggest failure points of development teams you've seen?
Yeah, in our experience so far, definitely defocusing is a major problem. We switched to a mode where we try to focus on two priorities tops. We're going to get this quarter and this other thing. And, you have a multidisciplinary things. It will have to be, like it might be next generation of robot and this autonomy software release. And those are the things that matters. And we're going to get those done and then sequencing other things so that you're not doing 8 things at once. Because context switching is a real problem. And doing too many things is a lot to track as well. And so if you're doing 8 different things, one of them is going to be going in a direction you're not paying attention to because you can't keep track of that much stuff, even though you can put it all on your spreadsheets and you can think you have it all in your head, but you're not giving, your attention is going to be divided 8 ways. And therefore you're not giving as much attention. So you're not asking maybe 5 whys, you're asking 2 whys, on each task, type of thing. And so we found that, focus, is a really big component. And if you start to get a lack of focus, it can really slow down everything because people are context switching. It can, make communications a big part of the time use at your company. And it can also, honestly, it can demotivate people in other ways as well. Because a lot of people are motivated by actually accomplishing a thing. And so the other thing that actually happens too, when you defocus, is you end up with what I call our stubs or things that have been started but not completed.
Okay. That makes sense. That's a backlog that you do not want to see in your project management.
No, that's wasted money.
Yeah. And this is the mentality that brought you guys to, complete a lot of projects. Actually, but measuring, you guys are measuring a lot of things. I know, like we talked about this briefly when we first met, but then now you mentioned it again. There's a data feed that goes back to you guys.
Yeah.
Customer use the product. So just 1 second, double clicking on this one. Do you know how many square feet you have painted of walls? Do you have a dashboard?
We do. So not painted, finished, which is an important. Yeah, we do have a dashboard. We're just south of 1 million. So we're in the 900,000 square feet, range right now. And, so we're pretty excited to get over that big milestone mark.
Party at the office at the million.
That's right. The 1 million square foot party.
And what do you use that data? So what kind of data do you collect and what do you use it for? Like, what's an example of the new feature shift because of a hint given by the data that goes back?
Yeah. Pretty much everything the machine's doing from, arm movements to, but a lot of the data that we really track is around utilization and, square footage, and then uptime. And so like we get, by the minute breakdowns of what state the machine's in, whether it's idle, whether it's e-stopped, whether it's actually functionally working, whether it's being driven to the next workspace, whether it's in drive assist mode. And you get a lot of information from that because what you're really getting is like a readout of what's happening on site. And so like that we literally don't get that in construction today. Like if you have a laborer doing something, you don't know what they're doing. You only find out like what happened maybe at the end of the day or maybe at the end of the week. And so we can dive in and say like, oh, wait a minute, they're idle for, 2 hours around, 9 a.m. to 11 a.m. What's going on there? We could proactively call them, just find out, hey, is there something we should know about? Sometimes we just find out that's when the safety meeting is. And so it's like, hey, how do we make workflows that go around that? Sometimes we find out that they keep running into an issue at about when they run out of their first mud drum, that this thing actually takes them a little longer time. And we can say like, oh, actually, if you do it this way, we'll save you half an hour. Or if you set that up at the beginning of the day, it's actually a more optimal workflow. So there's a lot of insight that you get just from, pretty basic, like what state is the machine in? And I think that's where the power is. And we look to expand on that. we want to get kind of like holistic mapping that to actual plans. So like, where are they in the building? When does downtime happen? Can you correlate the features? But that's all kind of like future stuff for right now.
Yeah. Okay. Super interesting. So you drive better customer experience by, silently listening in. That's fully clear. I love how deep we went into this. I'm sorry I drove you in a bunch of rabbit holes, one after the other.
Yeah.
It was really a rapid here. If I towards the finish up and kind of like the finishing line, I want to ask you, what do you see next? So where are you focused right now as a company? Meaning in terms of customers, what are the opportunities that you're seeing now? And what are the opportunities that you see in the future? Kind of like expanding your customer base, expanding your scope. And I don't know if you want to expand your product.
Yeah, I probably should say something about that in this podcast. Like I just corrected, we're focused on drywall finishing, which is the part of, making an interior wall. You hang a board on the studs. We don't do that yet. And then you have a non-flat surface that you need to put joint compound on to make it into a flat surface that then is ready to prime and paint. So we actually don't do the prime and painting either. We do that application of joint compound, and we do it by having a machine that sprays on the material in a precision profile and then sands it back after a drying cycle to a final finish. And this is really advantageous is because, it takes 4 days of iterative application for workers to put on joint compound, whereas we can do it in 2 days and one spray cycle. So huge advantages that come there. And so we're at an exciting spot at the company. We've just released our 3rd generation system, which is a mobile robot that has, ability to drive itself down walls and apply material. It's also equipped for ceilings, corners, a lot of the cases that we couldn't handle before. So with this new system, the exciting piece is we're kind of getting to the culmination of the core product for finishing, and we'll keep pushing on performance upgrades and software. But in general, that kind of hardware is done. And so what we're looking to going forward is then looking at expanding to areas we can't cover yet. And so this platform is designed for all your smallest spaces. So multifamily residential all the way up through airport, but only goes up to about 12 feet. We see a huge amount of value in spaces that are 30, 40 feet. So the next hardware iteration will be a complementary product to this that goes up to heights. And that's going to be really beneficial for our customers. And then alongside it, the other thing we're starting to look at doing is what other tools do we put in the hands of the robot? Painting is obvious, after the process we already do. But things like fireproofing, other things where you're applying materials in similar ways. We've gotten lots of requests for. So we're getting to that point where we can start to transition to thinking of those types of things. We've kind of culminated the full product for finishing.
Okay. Super interesting. I love that you're building a product platform. I think that's the key to go forward is you need to be able to control, change that in the factor, change what's, or at least, what are you applying? What are you manipulating with the same type of technology? And then, you make a product platform out of that. That's where your product suite stems up.
Yeah. Yeah. That's really the opportunity. Like, that's why we kind of consider this, like, when we think about it, it's really making the heavy equipment for interior spaces as opposed to just making a drywall robot.
Do you have a few customers that are almost primarily using Canvas equipment to do their jobs?
We're not at the point where they're only using that, and I don't think we will be in the foreseeable future. Just because there's so much variation on a site that a core part of our thesis and what we're trying to build is really, this is one of the tools in their tool belt. And so workers are using Canvas for all the places it's really useful, and that's going up and up. But there's always going to be a need for them to be using their expertise alongside it. And it's much more of kind of the way we see it is a worker operating 2 machines while collaboratively finishing themselves alongside it.
I love it. I think it's a great vision. I think it makes a lot of sense. And I love the entire throughout the entire interview, I think you were super adamant on like where you're driving your team towards. I think that speaks of great leadership. I don't think you have like, your own vision of what you want to do. I think there's in your head, there's a clear roadmap to what are the priorities that we'll have to take, over time to make this, to make this a reality. And I love that in a robotics CEO. So really kudos to that.
Well, I appreciate that, but I mean, I want to just turn that shout out to the team itself, because it, like I said, Regis, our VP of engineering, Maria, our CTO, like leaders on like the mechanical, electrical and software teams, like we're part of figuring this out and carrying that torch. And honestly, that's, if I have one job, is making sure to recognize those people, that are really doing that. It's not going to just come top down. So maybe just want to make sure I use that opportunity to give a shout out to those great leaders.
No, I also appreciate this one. And you've actually given a bunch, so we could list them back. But if you had to give one last kind of like overarching, could be very high level because you went very low level and I loved it. Advice for the founders listening. They're building hard things. They're building, stuff in industries that are really difficult to navigate, that do not have the tendency to be, very innovative, and they're really traditional. What would it be?
Yeah. High level, couple words. Success criteria and pain. What's your customer's biggest pain and what's the spec that will meet it, and be really just 100% focused on that and early. As early as you can learn that to design for it. That's probably my high level version.
Yeah. I mean, I love it. That's really condensed, but it makes a ton of sense. Thank you so much, Kevin. This has been super fun. Sorry to take a little bit more than I asked of your time, but I just loved it too much. I hope we can do a part 2, either on the back of a new fundraise, if you ever do one, or just anytime you feel like sharing new updates on Canvas, on this platform, you're just always welcome to shoot me an email.
I would be happy to. It was a great time. I appreciated the invite and the conversation today, Gabriel.
All right, Kevin, have a great one then.